What is Django? Django is a high-level Python web framework that enables rapid development of secure and maintainable websites. Built by experienced developers, it takes care of much of the hassle of web development, so you can focus on writing your app without needing to reinvent the wheel. Django follows the dry, don't repeat yourself principle, aiming to reduce repetition of software patterns by abstracting common functionalities, making the development process faster and less error-prone. It comes with a plethora of built-in features, such as an admin panel, database interfaces, and tools to manage user authentications, making it a comprehensive toolset for web development. Django's architecture. Django follows the Model View Template (MVT) architecture, which is a variation of the widely known Model View Controller (MVC) pattern. The primary goal is to separate business logic, interface, and data models, ensuring a clean, manageable code structure. Understanding each component's role is crucial for developing Django applications. In this code block, 1. A Django model is defined in the models module, representing the data structure, model. 2. A view function myView is created in views.py, handling a web request and returning a response, view. 3. An HTML file is defined under templates, presenting the data in a structured format, template. This illustrates Django's separation of concerns, whereby data handling, logic, and presentation layers are distinctly managed, aligning with the MVT architecture. MVC and MVT patterns. In software engineering, the MVC, Model View Controller, and MVT, Model View Template, patterns are architectural patterns used to separate an application into 3 main logical components. While MVC is a more general pattern, Django follows the MVT pattern, which is a variation of MVC. Understanding these concepts is crucial for organizing and maintaining code in a Django project. In the MVC pattern, model represents the data structure, view represents the display logic, and controller handles the input. Django's MVT pattern, however, splits responsibilities slightly differently. Model remains the data structure, template represents the presentation layer, akin to view in MVC, and view in Django corresponds to the controller in MVC, handling the business logic and user requests. Essentially, Django's view acts as a bridge between the model and template, deciding what data to display and how, making it a fusion of MVC's view and controller concepts. Why choose Django? Choosing the right framework for your project is crucial for its success. Django, a high-level Python web framework, enables rapid development of secure and maintainable websites. Let's explore the reasons to choose Django. Django is preferred for several reasons. Firstly, its batteries included philosophy means it comes with numerous features out of the box, like the ORM, Object Relational Mapping, shown in the code, which abstracts database operations. Secondly, it emphasizes security, helping developers avoid common mistakes like SQL injection. Thirdly, Django's scalability and flexibility make it suitable for projects of any size. Lastly, its vibrant community and extensive documentation ensure support throughout development. Installing Django. To get started with Django, the first step is to install it on your development machine. Django can be installed easily using Python's package manager, pip. Before installing Django, make sure you have Python installed on your system, as Django is a Python web framework. The command pip install Django tells pip, Python's package installer, to download and install the latest version of Django from the Python package index, PyPI. Once the command is executed, pip handles the installation process of Django along with its dependencies automatically. After the installation, you can confirm the successful installation by running Django admin-ish version in your terminal to see the installed version of Django. Setting up a Django project environment. Setting up a Django project environment involves creating an isolated workspace on your computer. This is crucial for managing dependencies and ensuring your project runs smoothly across different setups. We'll use virtual env to create this isolated environment and pip for installing Django. The first command creates a virtual environment named myprojectenv using Python's built-in module venv. The second command activates the virtual environment. On Windows, use myprojectenv scripts that activate instead. After activation, your prompt changes to indicate that the virtual environment is in use. The last command installs Django within this environment, ensuring that your project's dependencies are managed separately from other Python projects on your system. Django project versus Django app. Understanding the difference between a Django project and a Django app is crucial for organizing your code efficiently. A project is the entire application, while an app is a component within the project that serves a specific function. This code snippet demonstrates how to create a new Django project named My Project, and within that project, a new app named My App. The Django admin start project command initializes a new project along with its necessary directory structure. The Python manage py startapp command creates a new app within the project, providing a scaffold for app-specific models, views, and templates. Each app should perform a single, focused task, contributing to the modularity and reusability of the code. Running a Django development server. After setting up your Django project, the next step is to run it locally to see the web application in action. Django comes with the built-in development server, which is very useful for testing your project during development. Here's how to start the Django development server. This command starts the Django development server. Python tells your computer to use Python to execute the script manage.py with the argument runServer. The development server runs on your local machine, allowing you to view your Django project by visiting http:/127.01.8000 in a web browser. This server should only be used for development purposes, as it is not designed to handle real-world traffic efficiently. Understanding Django models. Django models are a crucial part of any Django application. They define the structure of the database. A model in Django is a special kind of object. It is saved in the database. Each model maps to a single database table. The basics of Django models include defining the model fields and their data types. In this code snippet, we define a simple model named book using the Django ORM, Object Relational Mapping. The book model has three fields: title, author, and published date. The models.char field is used for title and author fields to store text, and models.date field is used for published date to store a date. Each instance of book will correspond to a row in the database table named book. Django automatically generates the table name in lowercase. This model allows Django to create, read, update, and delete records in the database table corresponding to the book model. Defining models in Django. In Django, models are Python classes that define the structure of your database. Each model maps to a single database table, and each attribute of the model represents a field in that table. Defining models is essential for creating database tables and for querying data. Let's define a simple model for a blog post. In this code snippet, we define a model named blog post by subclassing django.db.models.model. This model represents a blog post in our database and has three fields: title, content, and pub date. The title field is defined as a char field, which is suitable for short to medium-sized strings with a maximum length of 200 characters. The content field uses text field, which is ideal for large text bodies. Lastly, pub date is a date time field that stores the date and time the blog post was published. This simple model serves as the basis for creating a blog post table in the database and for performing database operations on blog posts. Django's ORM, Object Relational Mapper. Django's Object Relational Mapper, ORM, is a powerful tool that maps objects defined in Python code to database tables. It abstracts the process of storing data in a database, allowing developers to work with high-level Python objects instead of SQL queries. Here, we'll define a simple model to represent a blog post and demonstrate how to perform basic operations. This code defines a Django model, blog post, representing a blog post in a database. It is created by subclassing django.db.models.model. The class attributes, title, content, and published date, define the database fields for the model. Title is a char field suitable for short to medium length strings. Content is a text field for larger text contents. And published date is a date time field that automatically sets its value when a blog post instance is first created. The star method returns a string representation of the model, typically using a title or name attribute. This model can then be used with Django's ORM to create, retrieve, update, and delete records in the database related to blog posts without directly writing SQL queries. Migrations. Migrations in Django are a way of propagating changes you make to your models, adding a field, deleting a model, etc., into the database schema. They are designed to be mostly automatic, but they still require some understanding and manual handling from time to time. The Make Migrations command looks through your project for changes to your models that require migrations and creates new migration files containing those changes. The Migrate command applies these changes to your database, creating new tables, fields, or altering existing ones to match your models. It ensures your database schema matches your current Django models. Working with Django Admin. The Django Admin is a powerful and auto-generated interface provided by Django to manage the database. It enables administrators to create, view, modify, and delete records. To start using it, you first need to create an admin user. Then, you can register your models to make them accessible through the admin interface. This code snippet demonstrates how to register a model with the Django admin. First, you import the admin module from django.contrib and the model you want to register from your models, in this case, my model. Then, you use the admin.site.register method to register the model, making it available in the Django admin panel. This enables the admin user to perform CRUD operations on my model instances directly via the web interface. Registering models in Django admin. To make your models available in the Django admin interface, you need to register them. This involves making modifications to the admin.py file in your Django app. By registering a model, you enable the administration interface to interact with it, allowing you to add, delete, and edit records of that model. Here's how you can do it. In this code snippet, we first import the admin module from django.contrib and the model, my model, from the models.py file within the same app. Then by calling admin.site.register my model, we register the my model with the Django admin site. This simple step makes my model appear on the admin page, where you can manage its records. It's essential for making models accessible to administrators or users with the necessary permissions. Query sets and managers. In Django, a query set is a collection of database queries for retrieving objects. The manager is the interface through which database query operations are provided to Django models. Each model has at least one manager, and you can create custom managers for custom behaviors. This code snippet demonstrates how a default manager, objects, and a custom manager, custom objects, can be used in a Django model, my model. The default manager provides basic query methods, like all, which retrieves all objects from the database. A custom manager, my model manager, can be defined with custom methods, some method, to include additional logic for querying. The managers enable executing database queries directly from the model, encapsulating the SQL logic behind Python methods. Relationships, foreign key, many-to-many field, one-to-one field. In Django, relationships between models are defined by three key field types: foreign key, many-to-many field, and one-to-one field, each serving different types of database relationships. Foreign key is used for one-to-many relationships, many-to-many field for many-to-many relationships, and one-to-one field for one-to-one relationships. In the code snippet, the author and book models demonstrate a one-to-many relationship via foreign key, allowing multiple books to be associated with a single author. The profile model illustrates a one-to-one relationship with the user model using one-to-one field, perfect for extending user information. Lastly, the course and student models show a many-to-many relationship using many-to-many field, enabling students to enroll in multiple courses and courses to have multiple students. These relationships create a rich set of connections between data in your Django applications. Model inheritance. In Django, model inheritance allows you to base one model on another, meaning you can create a new model that inherits fields from an existing model. This is particularly useful for reusing common information and behavior. Django supports three forms of inheritance: abstract base classes, multi-table inheritance, and proxy models. Here we'll focus on abstract base classes. In this example, common info is an abstract base class model with fields name and age. By setting abstract equals true in the meta class, it won't create a database table for common info. Instead, any model that inherits from common info will include its fields, alongside any additional ones declared in the child model. Student is such a model, inheriting from common info and adding a home group field. It's a simple yet powerful way to reduce redundancy and keep your code dry. Custom managers and query sets. In Django, models represent tables in your database, and managers are the interface through which you query these tables. By default, Django provides a basic manager objects for every model to execute database queries. However, for more complex queries, defining custom managers and query sets can keep your code organized and reusable. Let's create a custom manager to filter published posts. Here, we define a published manager that extends django.db.models.manager. Within it, we override the getQuerySet method to modify the default query set. This method uses super to call the parent class's getQuerySet method, then chains up filter status equals published operation to fetch only those posts with a status of published. We then attach this manager to the post model as a new manager alongside the default objects manager by defining a class attribute published equals published manager. Now, when accessing post.published.all, Django will return only the posts that have been marked as published, thanks to our custom manager. Understanding views. In Django, a view is a Python function that takes a web request and returns a web response. This response can be HTML contents of a web page, a redirect, a 404 error, etc. A view accesses data through models and delegates formatting to the templates. This code defines a simple view called myView, which takes a request object as an argument and returns a response object using HTTP response. The response in this case is a text "Hello World." When Django receives a request, it needs to decide which view should handle the request. This is where URL confs come into play to map URLs to views. Function views versus class-based views. In Django, views are a crucial element, determining what a user sees when they make a request to a web application. There are two primary ways to define views: function views and class-based views. Function views are simple and straightforward, defined as a single function. Class-based views, on the other hand, leverage object-oriented principles, offering reuse and extendability by defining views as classes. In the provided code, myFunctionView is a function view that takes a request object and returns an HTTP response directly. This approach is quick for simple views. The class-based view myCBView, inheriting from Django's view class, defines its behavior through methods corresponding to HTTP verbs, e.g. get. This separation of HTTP methods can make handling different types of requests within the same view more organized. Class-based views are especially powerful when dealing with repetitive patterns and can be easily extended or mixed with other components. Configuring URLs. In Django, configuring URLs correctly is crucial for directing users to the correct views. This involves creating a URL pattern for each view you want to serve. The urls.py file in your Django project or app is where these URL patterns are defined using the URL or path functions. This code snippet demonstrates how to define URL patterns in a Django application. The URL patterns list contains mappings between URL path expressions and view functions. The path function is used to define each mapping. The first argument is a route string that matches a URL pattern, and the second argument is the view function that should be called for that pattern. Optional third arguments, like name, allow you to name your URL pattern, making it easier to refer to it elsewhere in your code, especially in templates. The int year segment in the second pattern is a path converter that matches one or more digits and passes them as an integer to the view function. Passing data to views. In Django, views are Python functions or classes that take a web request and return a web response. You can pass data to views via URL parameters, which can then be used to dynamically control the output of your views. This mechanism is particularly useful for creating dynamic content based on user input or other variables. In the code example, we define a view function greetUser that accepts both a request object and a username string as parameters. The username parameter is passed from the URL defined in URL patterns. The URL pattern greet username / captures a string after greet and passes it to the greet user view as the username variable. This allows the view to dynamically customize the HT response based on the username captured from the URL. When a user visits a URL like /greetjohns, the greet user view responds with "Hello, John." Handling dynamic URLs. In Django, dynamic URLs allow you to capture values from the URL path and pass them to your views. This is particularly useful for creating RESTful interfaces, where the URL contains identifiers for resources. Below, we illustrate how to configure a URL conf to capture a dynamic value from the URL and how a view might use this value. In this example, the URL pattern includes a dynamic segment, int yesh, that captures an integer and passes it as an argument to the year archive view function defined in views.py. This means when a user accesses a URL like articles 2023, Django recognizes 2023 as the year parameter and passes it to the year archive function. The int part is a converter that ensures the captured value is of the expected data type, in this case an integer. Namespacing URL names. In Django, URL namespacing allows you to uniquely reverse named URL patterns, even if different applications use the same URL names. It's particularly useful in larger projects with multiple apps that might have overlapping URL names. Namespacing ensures that when you use the URL sent template tag or the reverse function to generate URLs, you can specify exactly which URL you want, avoiding any ambiguity. In the code, app name equals pols sets the application namespace for the URL conf module. This means that every named URL in this Django app can be uniquely identified with the prefix pols. For example, to reverse the index view in the pols app, you would use reverse pols index, or sent URL pols index % in a template. This approach is beneficial when you have multiple apps with a view named index. The namespace ensures you're pointing to the correct one. Creating reusable templates. A significant advantage of using Django's templating system is the ability to create reusable templates. These templates can include common structures or elements that you use across different pages of your web application, like headers, footers, and navigation bars. This approach promotes DRI, don't repeat yourself principles, making your project more maintainable. In this code, base.html is a template that defines a common structure for your site. This might include HTML layout, header, footer, and other common elements. By using extends base.html%, another template can inherit all these common elements. The sent block content descent is a placeholder within base.html that allows child templates to insert their specific content. So the content between sent block content sent and sent end block sent in the child template gets inserted into the corresponding block in the base.html. This mechanism allows for a powerful way to maintain consistency across your site while still allowing for page-specific content. Template inheritance. Template inheritance is a powerful feature of Django that allows you to build a base. In this example, the child template inherits from base.html using the sent extends base.html sent tag. Template tags and filters. In Django, template tags and filters provide a way to process data for display. Template tags are enclosed within sent and perform various tasks, such as loops or conditionals. Filters, denoted by variable filter, modify variables for display, such as formatting dates or managing strings. In this code snippet, an if template tag checks if a user is authenticated. If true, it greets the user by name, using the title filter to capitalize the first letter of each word in the user's name. If false, it greets with "Hello guest." It demonstrates basic conditional logic and the use of a filter within a Django template. Securing views. In Django, securing views is crucial for protecting sensitive data and functionality from unauthorized access. Django provides several decorators and mechanisms for this purpose, such as requiring login for certain views or restricting access based on user permissions. Let's explore how to use the login required decorator to secure a view. In the code snippet above, the login required decorator is imported from django.contrib.auth.decorators and applied to my secure view. This decorator ensures that only authenticated users can access this view. If an unauthenticated user tries to access it, Django redirects them to the login page, defined in the project settings via login URL. It's a simple yet effective way to secure a view by requiring users to be logged in. Django Forms Basics. In Django, forms provide a powerful mechanism to handle user input, simplifying the creation of HTML forms and the processing of submitted data. Django forms take care of generating form elements in HTML, validating submitted data, and converting that data into Python data types. This code illustrates the basics of Django forms by defining a simple contact form with 3 fields: name, email, and message. The forms.form class is subclass to create the form, where each form field is represented by a class attribute and associated with a specific form field class. The char field and email field are used for text and email inputs, respectively, with maximum length validation. The message field uses a text area widget to create a larger text area for input. Each field also includes a user-friendly label. This form class can then be used in views and templates to render an HTML form, process submitted data, and display form errors. Field types. In Django, forms are a powerful mechanism to accept input from users and perform validation. Django forms come with a variety of field types that correspond to HTML form elements, such as text inputs, checkboxes, and dropdowns. Each field type in a form class handles the conversion between raw values from the form and Python data types. In the contact form example, char field is used for text input, appropriate for short text strings. It corresponds to input type text in HTML. The max length parameter limits the number of characters. For longer text, such as messages, char field with a text area widget is employed, creating a larger text area in the HTML form. Lastly, integer field is used for age, accepting only integer values. The min value parameter ensures that only non-negative ages can be entered. These field types automatically handle data conversions and validations. Widgets. Widgets in Django forms are the core components that determine how form fields translate into HTML. They manage form field presentation and input elements, enabling customization of form components. Understanding how to leverage widgets can significantly enhance the user experience. In this example, we define a form with 2 fields, name and message. For the name field, we use a text input widget, adding HTML attributes such as class and placeholder via attrs. This customization will render the input for the name field with the specified CSS class and placeholder text. For the message field, we use a text area widget, specifying its size with rows and cols. This demonstrates how widgets allow for close control over the formatting and attributes of form fields, improving the interaction and presentation of forms. Form validation. Form validation is a crucial aspect of Django forms, where it checks the data submitted by a user against certain criteria before processing it. This is essential to ensure data integrity and security. Django provides built-in methods for validation, but also allows for custom validation rules. In this example, a simple form with an integer field for age is created using Django's forms framework. The cleanAge method is a custom validation method specifically for the age field. Inside this method, we access the submitted data using self.cleanDataAge. A check is performed to ensure the age is at least 18, and if it's not, a validation error with a message is raised. If the validation passes, the validated data is returned, making it available for further processing. This demonstrates how Django enables both field-specific and form-wide validations. Model forms. Model forms in Django attach forms automatically to models. This feature makes it easy to create forms that include the necessary HTML input elements based on the model fields. Instead of manually defining each form field, you let Django handle it with model form. In this code, we import Django's forms module and the book model from the models file within the same app directory. We define book form, which inherits from forms.modelForm. Inside, we create a class meta where we specify the model the form is for, model equals book, and the fields we want to include in our form, fields equal title, author, summary. Django automatically generates the necessary form fields for these model fields. Custom validators. Custom validators in Django allow you to define your own validation rules for form or model fields beyond the built-in ones. This is particularly useful when your application requires specific criteria to be met by user inputs, such as a custom range, format, or condition. Here's how to create a custom validator to ensure a number is not greater than a specified limit. The code defines a custom validator function, validate not greater than limit, which checks if the input value is greater than 100. If the condition is met, It raises a validation error with a customized error message, indicating the value and that it exceeds the maximum allowed limit. This function can be used in Django forms or model fields as part of their validators list, enabling you to enforce this rule wherever needed in your Django application. Handling GET and POST requests. In Django, handling GET and POST requests allows your application to interact with user input in a meaningful way. GET requests are typically used for retrieving data, while POST requests are used for submitting data. Here's a simple way to differentiate and handle these requests in your Django views. In this example, we define a view named myView within your views.py file. The view first checks the request method. If the method is POST, it means the user submitted data, e.g. via a form, and we handle the data appropriately, responding with a simple HTTP response. Conversely, if the method isn't POST, we assume it's a GET request. In this case, we're simply rendering a template called mytemplate.html. This basic structure allows you to separate logic for different request types, helping to make your application more modular and easier to manage. Form sets. Form sets in Django are a simple way to handle multiple forms on a single web page. They are especially useful when you want to allow users to input, edit, or submit multiple objects of the same form simultaneously. Form sets manage the complexity of handling multiple instances of forms, including validation and rendering processes. In the provided code, we first import necessary components from the Django.forms module. We define a simple article form class with title and content fields. Next, we create a form set article form set using the form set factory function, specifying the form class it should manage, article form, and an extra parameter, which indicates the number of empty forms to display. The extra equals 2 means the form set will include 2 blank article forms by default. This setup allows users to submit multiple articles at the same time on the same page. Crispy forms for better form styling. Django Crispy Forms provides Django developers with an easy way to make forms in their web applications look attractive. It offers a simple integration with Django forms and leverages CSS frameworks like Bootstrap for styling. In this guide, we'll see how to install and use Crispy Forms to improve the look of a Django form. In the provided code, example form extends the forms.form class, adding fields for name and age. What makes this form crispy is the use of form helper from crispyforms.helper. Form helper is initialized in the forms constructor, setting the forms method to POST. Finally, a submit button is added using submit, which is styled automatically by Crispy Forms. This setup, when rendered in a template with sent crispy form sent tag, will produce a beautifully styled form without manually writing any CSS. User authentication system. Django's user authentication system handles user accounts, groups, permissions, and cookie-based user sessions. This built-in system makes it easier to create secure web applications. Let's explore how to authenticate a user, check their authentication status, and log them out using Django views. The code demonstrates user authentication in Django. Firstly, it includes Django's authenticate function, which verifies a user's credentials. If successful, the login function attaches the user to the current session. Checking whether a user is authenticated in a view is done using request.user.isScoreAuthenticated. Finally, to log the user out, Django's logout function is used, effectively ending the user session. It's essential to remember that these require the user model and authentication system to be set up in Django's settings. Creating user accounts. In Django, creating user accounts allows individuals to gain access to and interact with your application in a secure manner. Django's built-in user model makes this process straightforward. You can create user accounts directly from the Python shell or programmatically within your views or forms. Let's focus on creating a user account programmatically. The code snippet uses the createUser method available on Django's user model to create a new user account. The required arguments are username, email, and password. This method automatically hashes the password, making it secure. After creating the user object, calling save persists the user to the database. Now, the new user can log in with their credentials. This process is essential for any web application requiring user registration and authentication. Authenticating and logging users in and out. Django provides an authentication system that handles user accounts, groups, permissions, and cookie-based user sessions. This topic covers how to authenticate a user, log them in, and log them out. The code snippet demonstrates the process of authenticating a user with a username and password, logging them in, and then logging them out. First, the authenticate function checks if the provided credentials match with any user in the database. If a match is found, the login function attaches the user to the current session, effectively logging them in. To log out, the logout function is called, removing the user from the current session. It's important to manage user sessions securely to protect against unauthorized access. Customizing authentication with user models. Django's built-in user model covers many use cases, but sometimes you need to store additional information about users or use a different form of identification. In such cases, you can extend the existing user model or replace it entirely with a custom model. Here's how to create a custom user model by extending abstract base user and adding custom fields. This snippet defines a custom user model myUser that uses an email address for identification instead of a username. It extends abstract base user to include Django's authentication backend functionalities. The custom field is an example of how you can add additional information specific to your application. The username field is set to email to specify the unique identifier for authentication purposes. A custom manager myUserManager is defined, which must include methods to create users and superusers necessary for Django's admin and the authentication process. This setup provides a foundation, but remember to implement user creation methods in the manager for it to function properly. Permission and authorization. In Django, permissions and authorization are mechanisms to control access to certain parts of a web application based on the user's identity. Permissions determine what a user is allowed to do, while authorization is the process of granting or denying those permissions based on rules. In this example, the login required decorator from Django's authentication framework is used to protect a view by checking if the user is logged in before granting access. If the user is not authenticated, Django will redirect them to the login page. This is a basic form of authorization, where the rule is simply whether the user is logged in or not. Group and user permissions. Django's framework includes a powerful system for managing groups and user permissions, which allows for fine-grained access control over what authenticated users can and cannot do. This system is built around three core models: user, group, and permission. Users can belong to groups, and groups can have various permissions assigned to them. Permissions can also be assigned directly to users. This code snippet demonstrates how to create a new group, assign a permission to that group, and then add a user to the group. Firstly, a new group named newGroup is created using group.objects.getOrCreate. Next, a permission, in this case the permission to add log entries, represented by addLogEntry, is fetched using permission.objects.get and added to the group's permissions. Finally, a user, in this case a user with the username John, is added to the group using user.groups.add. This setup allows the user John to inherit the permission to add log entries, as it is a permission of the group he's now a part of. Working with Django's built-in decorators. In Django, decorators are a powerful feature that allows us to modify the behavior of function or class methods, especially for authentication and permissions in views. Built-in decorators, like login required, permission required, and user passes test, can help control access to views based on a user's authentication status or permissions. In the provided code, we use the login required decorator from Django's auth module. This decorator is applied to a view function, myView. It ensures that only authenticated users can access this view. If an unauthenticated user tries to access it, they are redirected to the login page. The login required decorator is a straightforward and effective way to restrict access to certain parts of a web application to logged-in users. Password management. Django provides a comprehensive system for managing user passwords. This includes hashing for secure storage, utilities for password setting and changing, and password validation. Here we'll explore how to create a form for users to change their passwords. This example shows how to instantiate and handle a password change form, which is part of Django's auth module. First, we import the form from django.contrib.auth.forms. This form requires the current user instance, passed when creating the form object. If handling a post request, we recreate the form with submitted data. To validate the form, we call form.isValid. If valid, form.save updates the user's password. After saving, additional steps such as re-authenticating the user or redirecting to a confirmation page can be implemented. Database transactions. In Django, database transactions ensure that a series of database operations either complete successfully as a group or have no effect at all. This concept is crucial in maintaining data integrity in applications, preventing partial updates that can cause data inconsistency. Here, we use django.db.transaction to ensure that the operations within the withTransaction.atomic block are treated as a single unit. If an operation in this block fails, causing an exception, Django will roll back any changes made up to that point, essentially treating the operations as if they never happened. This prevents partial updates that could lead to data inconsistency. Aggregation and annotation. Aggregation in Django allows you to perform calculations over a set of records, such as calculating the average, minimum, maximum, sum, and count of a particular column of the database. This is especially useful when you want to compute summary values of your dataset directly in your Django application. In this code snippet, we import the avg function from django.db.models for calculating an average. We then query the book model to calculate the average price of all books in the database. The aggregate function takes the avg function passed with the field name price as an argument. The result is a dictionary, where the key is the name provided for the aggregation, price avg by default, and the value is the calculated average. Signal handling. Signals in Django allow certain senders to notify a set of receivers when certain actions have occurred. They're especially useful for decoupling different parts of an application. The pre-save and post-save signals are commonly used with models to execute logic before or after an object is saved. In the provided code snippet, we've connected to the pre-save signal for a Django model named myModel. The @receiver decorator is used to link the function myOrModel_preSave with the pre-save signal for myModel. This means right before any instance of myModel is saved, Django will execute myModel_preSave. Inside this function, we manipulate the instance by setting its name attribute to an uppercase version of whatever the name was initially. This change will therefore be saved into the database, demonstrating a simple way to modify model instances automatically before they're saved. Database indexing. Database indexing is a technique used to speed up the retrieval of records from a database table by reducing the number of disk accesses. In Django models, you can create indexes on one or more fields using the meta class options or field options. Indexes are particularly important for improving performance on large datasets. In the provided code, we create a Django model named book with 3 fields: title, author, and published date. To improve the query performance, especially when filtering by the published date, an index is added specifically to the published date field within the meta class of the book model. The indexes option in the meta class takes a list of index instances, where each index instance specifies the fields to be indexed and an optional name for the index. This index helps in faster retrieval of records by published date, reducing the number of disk reads required. Custom model fields. Django provides a variety of built-in model field types, allowing for a broad range of functionality out of the box. However, there can be situations where the built-in fields do not meet your requirements. In such cases, Django allows you to define custom model fields, offering a way to encapsulate specific database behavior, validation, or adaptations you need. Here's an example of how to create a custom model field to handle complex data types. In this code snippet, we define compressed text field, a custom Django model field derived from text field. The primary objective is to automatically compress text data before saving it to the database and decompress it when retrieving. We override the fromDBValue method to handle data coming from the database, decoding the compressed data with zlib. The toPython method is used for converting the database value to the Python object. Lastly, the getPrepValue method prepares data before saving it into the database, compressing the string data. This example demonstrates creating a custom field to add unique data handling logic within the Django ORM. Model metadata options. In Django, model metadata is anything that's not a field, such as ordering options, ordering, database table name, DB table, or human-readable singular and plural names, verbose name and verbose name plural. This metadata is declared inside a class meta, nested within the model class. In this example, the person model class includes several metadata options inside the meta class. 1. Ordering equals birth date. Dictates how the results of a query to the model will be ordered by default. In this case, it's in descending order based on the birth date field. 2. DB table equals person info sets the specific database table name for this model. If omitted, Django would automatically generate a table name. 3. Verbose name equals person, and verbose name plural equals people define human-readable names for the model, useful for the admin interface or other areas where the model's name needs to be displayed. Manager methods. In Django, managers are the interface through which database query operations are provided to Django models. By defining custom manager methods, you can enrich your models with more readable and convenient ways to query your database. This code snippet defines a custom manager, book manager for the book model. The manager includes a method, title count, which takes a keyword as a parameter and returns the count of books that contain the keyword in their title. By assigning book manager to objects in the book model, you replace the default manager with the custom one. Therefore, when you call book.objects.titleCount Django, it executes the title count method on all book instances, filtering titles that contain Django, and returns the count. This makes querying your database for specific conditions more intuitive and encapsulated within the model's scope. Introduction to API development. API stands for Application Programming Interface. It serves as a bridge between different software applications, enabling them to communicate with each other without needing to know how they're implemented. This is crucial for developing scalable and modular software systems. In simple terms, think of an API as a menu in a restaurant. The menu provides a list of dishes you can order, along with a description of each dish. When you specify which dish you want, the kitchen, the system, prepares the dish and serves it. In this analogy, the menu is the API, your order is the request, and the dish that is served to you is the response. Understanding RESTful APIs. REST, or representational state transfer, is an architectural style for designing networked applications. It suggests that requests and responses between clients and servers should be stateless and resource-based. In the context of Django, it's about creating web APIs that adhere to REST principles, making them predictable and standard across different applications. In this code snippet, we define a simple API view using Django REST Framework. API view is a class provided by DRF that we extend to create our own views. In the Hello World class, we define a GET method, which is responsible for handling GET requests. When a GET request is made to this view, it responds with a simple JSON object containing a greeting message. This demonstrates how to create a basic RESTful endpoint with Django REST Framework, responding to client requests with a resource message, Hello World, in a stateless manner. Setting up Django REST Framework. To use Django REST Framework, DRF, we first need to set it up in our Django project. This involves installing the framework, adding it to the installed apps in our Django project settings, and possibly creating a simple API to test that everything is working as expected. Let's start with the installation and basic setup. This snippet demonstrates the initial steps required to integrate Django REST Framework into your Django project. First, we install the framework using pip, Django's recommended package installer. Then, we add REST Framework to the installed apps list in the settings.py file of our Django project. This step is crucial, as it lets Django recognize the REST framework's availability, making its functionality accessible in your project. This setup allows you to start defining serializers and view sets for creating RESTful APIs with Django. Serializers and model serializers. Serializers in Django REST Framework are responsible for converting complex data types, like query sets and model instances, into JSON so they can easily be rendered into content types or used in templates. Model serializers offer a shortcut for creating serializers by automatically determining the set of fields, simple default implementations for the create and update methods. In this code snippet, we start by importing the necessary classes from Django REST Framework and the model we want to serialize. Then, we create a model serializer for myModel. By setting models myModel in the meta class, we tell Django REST Framework which model to serialize. The fields equals all instructs the serializer to include all model fields in the serialization. This automates much of the work in creating API responses, reducing the amount of code you need to write. Function-based views versus class-based views in DRF. In Django REST Framework, DRF, views determine how we handle requests for our web APIs. Function-based views, FBVs, and class-based views, CBVs, offer different approaches to writing view logic. FBVs are straightforward and procedural, while CBVs provide a more structured and reusable approach through inheritance and mix-ins. The code illustrates the fundamental difference between FBVs and CBVs in DRF. The FBV myFBV is a simple function accepting a request and returning an HTTP response. It's concise for simple logic. Conversely, the CBV myCBV inherits from API view, a base class provided by DRF. CBVs encapsulate the request handling within class methods, e.g. get for handling GET requests, offering a more organized structure that's beneficial for handling more complex logic, allowing for reusability and extension of the class's functionality. CBVs also facilitate the use of DRF's mix-ins and generic views for common patterns in API development. Authentication and permissions in DRF. Authentication and permissions in Django REST Framework, DRF, are crucial for determining who can access your API and what actions they are allowed to perform. DRF offers various authentication schemes like basic authentication, token authentication, and others. Permissions further refine access control by specifying what authenticated users can or cannot do. In the provided code, we define an API view class example view, which uses token authentication for authenticating users, and the isAuthenticated permission to ensure that only authenticated users can access the view. Authentication classes is set to a list with token authentication, which requires users to provide a valid token. Permission classes is set with isAuthenticated to restrict access to authenticated users only. The GET method defines a simple GET request that returns a message if the user is authenticated. Viewsets and routers. Viewsets in Django REST Framework offer an abstraction over traditional views, making it easier to develop CRUD, create, read, update, delete operations without writing multiple view classes. Routers work seamlessly with viewsets to automatically generate URL configurations for your API. In the provided code, your model viewset is a subclass of model viewset that tells DRF how to handle CRUD operations for the yourModel model, utilizing the yourModel serializer for data serialization. The default router is then used to automatically create the API URLs for these operations. The register method links the viewset with a URL prefix, yourModel, creating routes for standard operations like list, create, retrieve, update, and destroy. This setup minimizes the amount of code needed for URL configurations, making API development faster and more efficient. Pagination. Pagination is essential in API development for limiting the results returned by a query to manage response size and improve performance. Django REST Framework, DRF, offers built-in pagination styles that can be easily added to your API views. Below is an example of how to implement pagination in a DRF view. In this snippet, page number pagination is used, which divides the result set into individual pages. The myModel list view inherits from API view and utilizes pagination. The get method fetches all instances of myModel, then uses the paginate query set method to paginate the query set. If pagination is successful, it serializes the page's data and returns it using getPaginated_response to include pagination information in the response, like links to the next and previous pages. If there are too few items to paginate, it serializes and returns the entire query set. This approach keeps your API responses manageable and improves client-side data handling. Testing APIs. In the context of building web applications with Django and Django REST Framework, testing APIs is crucial to ensure that your application behaves as expected. This involves sending various HTTP requests to the API endpoints and verifying the responses. Let's start with a simple test case to check if our API returns the correct HTTP status code and response content. In this code snippet, we're using Django REST Framework's API test case class to create a test case for our API. We define a test method called testExample within our example API test class. Inside this method, we use self.client.get/API/example/ to send a GET request to our API endpoint. We then check if the status code of the response is 200, indicating success, and if the word success is present in the JSON response. This basic test ensures our API endpoint reacts correctly to GET requests and returns the expected content. Why testing? In software development, testing is a critical step that ensures your application behaves as expected under various conditions. Django, being a high-level Python web framework, emphasizes the importance of testing to build reliable and maintainable web applications. Let's understand why testing is essential in Django. Testing in Django helps catch bugs early in the development process, reducing the cost of fixing them later. It fosters confidence in adding new features or refactoring code, knowing it won't break existing functionality. Tests serve as documentation, describing how your application should behave, making it easier for new developers to understand the project's functionality. Furthermore, having a thorough test suite allows for continuous integration and deployment practices, ensuring your application can reliably be deployed to production at any time. Types of tests. In Django, tests are crucial in ensuring your application functions as expected under various circumstances. Django supports several types of tests, mainly unit tests, integration tests, and functional or end-to-end tests. This code snippet represents a simple unit test using Django's built-in test case class, which extends Python's unit test case. Unit tests focus on small, isolated sections of your application. Here, test animals can speak is a method to test that animals are correctly identified as speaking. Such tests are quick to run and help in identifying errors at an early development stage. Integration tests, on the other hand, focus on the interaction between different parts of your application, ensuring they work together as expected. Functional or end-to-end tests simulate user interactions with the application to ensure the entire application behaves correctly from start to finish. Choosing the right type of test depends on what aspect of your application you are trying to verify. Setting up test cases. In Django, test cases are Python classes that inherit from django.test.testCase. This subclass of Python's standard unit test.testCase provides additional Django-specific features. To set up a test case, you'll typically import your models and any other necessary components, then define a class that encapsulates the tests. This code snippet illustrates the creation of a simple test case for a Django model named myModel. First, it imports test case from django.test and the model myModel. Next, a test case class, myModelTestCase, is defined, inheriting from test case. Within this class, the setup method is used to set up any preconditions for the tests, such as populating the database with necessary objects. Here, an instance of myModel is created. Following that, the testModelStra method is a test that verifies if the stostr method of myModel acts as expected. By calling self.assertEqual, it asserts that the string representation of the myModel instance is correct. Testing models. Testing models in Django involves creating unit tests to ensure that your database models behave as expected. These tests should validate model constraints, default values, custom methods, and the integrity of your model instances. This code snippet demonstrates how to write a basic test case for a Django model named yourModel. It uses Django's built-in test case class. The test your model creation creates an instance of your model with name, set to sample name, and then checks two things: whether the instance is indeed an instance of your model, and if the name attribute of the instance matches the value provided during creation. This kind of test helps in verifying that model instances are correctly created and stored with the right attributes. Testing views. Testing views in Django involve simulating requests to your application and verifying the responses. Django provides a test client to make this process easier. This client allows you to mimic GET and POST requests on your views, and then inspect the responses to ensure they contain the correct content and status codes. The below example demonstrates how to test a view that renders a simple homepage. This code defines a test case for the homepage view. It uses Django's built-in test case class and the test client to simulate a request to the homepage URL, usually mapped to the home name in your URL conf. The test homepage status code checks that the response status code is 200, indicating a successful HTTP request. The second test homepage contains correct HTML, verifies that the response content includes the expected HTML snippet, welcome to the homepage. These tests help ensure that the view functions properly and returns the expected content. Testing forms. In Django, testing forms is crucial to ensure that they behave as expected. This involves checking form validation and ensuring that the correct forms are displayed based on different scenarios. Django's testing framework provides tools to test forms effectively. The code demonstrates how to test a Django form using the Django test case class. First, it imports necessary modules and the form to be tested. Then, it defines the test class example form test, which extends test case. Inside the class, two methods test the form's behavior in different scenarios. The test form valid method checks if the form is valid when correct data is provided, using the isValid method of the form instance. The test form invalid method tests the form's validation by providing incomplete or incorrect data, asserting that the form is not valid. This approach ensures that the form validates data as expected. Mocking. Mocking is crucial in unit testing for substituting external or complex dependencies with objects that simulate the behavior of the real ones. This allows tests to be focused, fast, and reliable. In Django, mocking is often used to simulate database calls, external API requests, or other services without actually performing these operations. In this example, we're using the unittest.mock.patch decorator to mock an external service. The @patch decorator replaces the function being mocked from path.to.external.service with a mock object for the duration of the test_my_function test method. We specify the return value of the mocked function as mocked response. When the my function that uses the mocked function is called within the test, it uses the mocked version instead of the real one. So the test can assert the expected behavior without relying on the external service's actual implementation. Integration tests. Integration tests in Django ensure that various parts of your app work together correctly. They are more extensive than unit tests and can cover interactions between your Django models, views, templates, and middleware. Here's how to write a simple integration test to check if a view correctly renders a template. In this example, test homepage is a test case that tests the homepage view. The test homepage renders correct template method checks if accessing the URL associated with the home view renders the correct home.html template. The reverse function is used to refer to the URL by its name, making the test more robust against URL changes. The assert template used method checks that the expected template was used to render the response. Test coverage. Test coverage is a metric used to measure the amount of code that is executed while the test suite runs. It's a crucial indicator of your test's effectiveness in checking the software's correctness. To measure test coverage in Django projects, we typically use the coverage tool. This tool can be installed via pip and integrated with Django's test framework to generate reports about which parts of your codebase are covered by tests. The commands shown begin with the installation of the coverage tool using pip. This is a necessary step before you can measure test coverage in your Django project. After installation, the coverage run command is used to execute your project's tests, with the -source option pointing to your project directory, indicated by. This tells coverage where to measure code execution. Finally, coverage report generates a readable report in the terminal, displaying which parts of your code were executed during tests, thus providing insights into test coverage. Understanding and improving these metrics is essential for ensuring your application is well tested and reliable. Configurations for deployment. Before deploying a Django project, it's vital to adjust its settings for the production environment. This involves ensuring security, efficiency, and sustainability of the application in a live setting. Here, we'll go through some key changes needed in the Django settings.py file. This code snippet is crucial for preparing your Django app for production. Setting debug to false hides detailed error messages to prevent information leakage. The allowed hosts list limits requests to your specified domain names, enhancing security. Enabling secure SSL redirect forces all traffic through HTTPS, protecting data in transit. Additionally, setting session cookie secure and CSRF cookie secure to true ensures cookies are only sent over secure HTTPS connections, preventing potential data interception. Working with WSGI/ASGI servers. In deploying Django projects, understanding the role of Web Server Gateway Interface (WSGI) or Asynchronous Server Gateway Interface (AS) is crucial. WSGI/ASGI serves as the interface between your Django application and the web server, ensuring that requests and responses are handled properly. Django comes with a built-in WSGI application, typically found in the wsgi.py file of your project, and similarly an ASGI application in as.py for asynchronous support. This code snippet demonstrates the basic setup needed to configure your Django application to work with WSGI servers. It imports the OS module to interact with the operating system and get WSGI application from Django's core to set up the WSGI application. By setting the Django settings module to your project settings, you inform Django which settings to use. Finally, application calls getWSGI application creates an instance of the WSGI application that the web server can use to forward requests to your Django project. Static and media files management. In a Django project, refer to project-wide assets such as style sheets, JavaScript, and images, while media files generally refer to the files uploaded by the users. Managing these files correctly is crucial for the performance and scalability of your application. This code snippet demonstrates how to serve static and media files during development by adding them to your URL patterns. Static helper function is used to append the static and/or media URLs to Django's URL patterns. When debug is true and you run server, this setup helps Django to serve files located at static root and media root under static URL and media URL paths. This setup should not be used in production. Instead, a web server like Nginx or Apache should serve these files. Security considerations. When deploying Django projects, it's essential to prioritize security to protect your application from threats. There are several configurations and practices to enhance your project's security. These settings in your Django project's settings.py file serve various security functions. Secure SSL redirect enforces HTTPS by redirecting all HTTP requests to HTTPS, improving data privacy. CSRF cookie secure and session cookie secure ensure cookies are only sent over HTTPS, preventing cookie theft. X-frame options set to deny prevents your site from being framed by others, mitigating clickjacking attacks. Secure Browser XSS Filter enables the browser's XSS filtering to stop cross-site scripting attacks. Secure Content Type NOSNIF prevents the browser from interpreting files as a different MIME type, avoiding MIME type security risks. Deploying to virtual private servers. Deploying a Django project to a virtual private server, VPS, involves transferring your Django application from your development environment to a live server where it can be accessed on the internet. This process requires setting up a web server, configuring a database, and ensuring your application's environment is secure and efficient. The code outlines the initial steps to deploy a Django project on a Linux VPS. It starts by connecting to your server via SSH. It then updates your server's package lists and installs necessary packages, including Python, pip, Python's package installer, development packages, Nginx, a web server, and Git. After the installation, a Python virtual environment is created and activated using Python 3-m venviv myprojectenv and source myprojectenv/binsh activate. This isolated environment is crucial for Python projects like Django to manage dependencies. Finally, Django Gunicorn, a Python WSGI HTTP server for Unix, and psycobg2 binary, a PostgreSQL adapter for Python, are installed within the virtual environment. Deploying to platform as a service, PaaS providers like Heroku. Deploying Django applications to Heroku involves a few simple yet critical steps. Since Heroku can directly interact with Git repositories, the deployment process is streamlined for developers. The key steps include creating a Heroku account, installing the Heroku CLI, preparing your Django project for Heroku, and using Git for deployment. The following example assumes you have a Django project ready for deployment. This code sequence facilitates the deployment of your Django project on Heroku. Heroku login commands the CLI to prompt for Heroku credentials, initiating the authentication process. Heroku Create My Django App creates a new app on Heroku with the name My Django App. Should you omit the app name, Heroku generates a random one for you. The Heroku git remote-a My Django App command links your local Git repository with the newly created Heroku app, enabling Git's deploy process. Finally, git push Heroku master pushes your code from the master branch of your local Git repository to Heroku, initiating the build and deploy process on Heroku's platform. After execution, Heroku automatically detects that it's a Python app, installs dependencies from your requirements.txt, collects static files, and deploys your project. Using Docker with Django. Docker is a popular tool for containerization, allowing you to package your Django application with all its dependencies into a single container. This makes deployment easier, more predictable, and scalable. The following example demonstrates how to use Docker with a Django project. This Docker file does the following. It specifies Python 3.8 as the base image, ensuring your container has Python installed. env python unbuffered1 makes Python output not buffered, making logs visible. A directory inside the container, /code, is created and set as the working directory. The current directory, dot, is copied into /code in the container. Python dependencies from requirements.txt are installed. Finally, the container's default command is set to run Django's development server, making the application accessible on port 8000. Continuous integration and continuous deployment, CI/CD, pipelines. CI/CD is a method to frequently deliver apps to customers by introducing automation into the stages of app development. The main concepts attributed to CI/CD are continuous integration, continuous delivery, and continuous deployment. CI/CD is a solution to the problems integrating new code can cause for development and operations teams, aka integration hell. In this simple CI/CD pipeline example, depicted in YAML format, we've defined 3 stages: build, test, and deploy. Each stage contains a script section where commands relevant to each phase are executed. Echo commands are placeholders representing where commands to build the application, run tests, and deploy the application would be placed, respectively. This illustrates a basic workflow where after committing code, the CI/CD system automates the process of building the application, running tests to ensure reliability, and finally, deploying the application to a production environment. Query optimization. In Django, efficient database querying is crucial for performance, especially as your application scales. The Django ORM, Object Relational Mapping, makes it easy to interact with your database, but misuse can lead to slow or inefficient queries. One common issue is the n+1 selects problem, which occurs when your code makes a new database query for each item in a collection, significantly increasing page load times. In this code, author.objects.all prefetch related books retrieves all authors from the database, along with a prefetch of their related books to prevent the n+1 selects problem. By using prefetch related, Django knows to fetch the related books in a separate query, but does so in an optimized way, reducing the overall number of queries. This method is particularly useful when you expect to access the related objects. This code will therefore execute a maximum of 2 queries, one for all the authors and one for all their books, regardless of the number of authors or books involved. This approach significantly improves performance compared to fetching each author's books in a separate query within the loop. Caching with Django. Caching is a crucial aspect of web development that significantly enhances the performance of web applications by storing copies of files or results of expensive computations for quicker access. Django offers a robust and flexible caching framework that can work at various levels, per view, per site, or the low-level cache framework for fine-tuned cache control. The provided code demonstrates how to implement view-level caching in Django. The cache page decorator is imported from django.views.decorators.cache and applied to a view function. The parameter 60-15 specifies that the view's response should be cached for 15 minutes. When a request is made to this view, Django checks if a valid cache exists. If it does, Django serves the response from the cache, bypassing the view logic. If not, the view is processed and the response is cached for subsequent requests. This simple mechanism can dramatically reduce server response times for frequently accessed views. Using Django's cache framework. Caching is a powerful feature in Django that allows you to store dynamic pages so they don't have to be calculated or retrieved from the database upon every request, significantly speeding up response times. Django's cache framework is versatile, supporting various backends like memcached, database caching, file-based caching, or even a local memory cache. In this example, myView checks if a value is stored in the cache with the key myKey. If it exists, cache.myKey retrieves the value, avoiding expensive recalculations. If it doesn't exist, the function perform expensive calculation is called to generate the result, which is then stored in the cache with cache.set, specifying a timeout of 300 seconds. After the timeout, the cache entry will expire, and the expensive calculation will be executed again if needed. This pattern significantly improves performance for computationally expensive operations. Middleware for performance enhancement. In Django, middleware are hooks into Django's request response processing. It's a lightweight, low-level plugin system for globally altering Django's input or output. For performance enhancement, middleware can be used for various purposes, such as caching, compression, or adding HTTP headers. Here, we'll focus on a simple middleware that adds caching headers to responses to improve client-side caching. This middleware aims to enhance performance by instructing clients to cache the content for a specified time, 1 hour in this case. It intercepts the response after it has been processed by the view, but before it is sent to the client. The patch cache control function modifies the response's cache control headers, setting max age to 3600 seconds, 1 hour, and marking it as public, indicating it can be cached by client browsers and intermediate caches. This technique reduces the need for repeated requests for the same resources, lowering server load and improving the user's experience by speeding up page loads. Database indexing. Database indexing is a performance optimization technique that speeds up data retrieval operations on a database table at the cost of additional writes and storage space. In Django, we can add indexes to model fields that are frequently queried to improve query performance. In this Django model, we define a book class with title and author fields indexed by setting db_index equals true. This means that Django will create database indexes for these fields, which makes querying books by titles or authors much faster. The publication date field isn't indexed, as the example assumes it's queried less frequently. By selectively indexing fields, we balance between performance gains on read operations and the overhead of maintaining indexes during write operations. Asynchronous views. In Django, asynchronous views allow for non-blocking request handling, which can improve the scalability and performance of your application. This is particularly useful for I/O-bound operations, such as database calls, network requests, or file reads, where the operation does not require constant use of the CPU. In the example, myView is defined as an asynchronous view using the async keyword. This allows it to use await for calling asynchronous operations like asyncio.sleep1, which simulates a delay, e.g., waiting for an I/O operation to complete. During this wait, Django can handle other requests, improving efficiency. Finally, the view returns a JSON response, which is Django's way of sending JSON responses. This async approach can significantly enhance responsiveness and scalability in Django applications handling I/O-bound operations. Static files optimization. In Django, static files refer to all the CSS, JavaScript, and images that are not dynamically generated. Properly managing and optimizing these files can drastically improve website performance. Below, we explore how to configure Django for the efficient handling of static files, specifically focusing on compression and caching. This configuration snippet achieves two major optimizations. Firstly, by including whitenoise.runServerNoStatic at the top of installed apps, it ensures that whitenoise takes over serving static files in development, bypassing Django's less efficient static files handling. The whitenoise middleware in the middleware setup then enables serving of compressed static files in production, making file sizes smaller and loading times faster. Lastly, setting static files storage to compressed manifest static files storage leverages whitenoise's ability to automatically manage file compression and versioning, ensuring browsers cache these files efficiently and only re-download them when they change. This overall setup reduces server load, speeds up page loads, and enhances the user experience by optimizing static file delivery. Security best practices. In Django, ensuring the security of your web application is crucial. Django provides several built-in mechanisms to help protect your application from security threats like SQL injection, cross-site scripting, XSS, cross-site request forgery, CSRF, and clickjacking. Following security best practices is essential for maintaining the integrity and privacy of your applications. The provided code snippet demonstrates the use of the @xframe options exempt decorator, which is a security measure against clickjacking attacks. Clickjacking involves tricking a user into clicking on something different from what the user perceives, potentially revealing confidential information or allowing others to take control of their computer while clicking on seemingly harmless web pages. This decorator exempts a particular view from the protection against being rendered in a frame, iframe, embed, or object. In Django, this is a part of the built-in security practices, and using it judiciously only when necessary helps maintain the application's security against such attacks. Custom template tags and filters. Django's templating system offers a wide array of built-in tags and filters designed to perform standard tasks. Nevertheless, there are times when the available tools don't meet your specific needs. In such cases, you can create custom template tags and filters to extend the template system's functionality. This allows for cleaner templates and the encapsulation of complex logic within Python code, rather than the template itself. In the code snippet above, we define a custom template filter named cut that removes all occurrences of a specified argument arg from a given string value. First, we import Django's template module and create a library instance. Next, we use the register.filter decorator to register our function as a template filter. In templates, you could use this filter as follows: some text, cut, allowing you to dynamically manipulate string content in Django templates. Signals in depth. Django's signals allow certain senders to notify a set of receivers when some specific actions have taken place. They're especially useful for decoupling applications. For instance, you might use a signal to automatically create a profile object when a new user instance is created. In this code, we're using the post-save signal, which is sent at the end of the save method of a model instance. We've connected this signal to a receiver function, createUserProfile, that creates a user profile instance whenever a new user instance is saved and the created parameter is true, indicating it's a new record. The @receiver decorator helps to link the signal with our custom function, specifying the signal post-save and the sender user. This decoupling allows for cleaner, more reusable code without modifying the user model directly. Advanced URL routing and patterns. When developing complex web applications with Django, you'll often encounter scenarios where the basic URL routing is not enough. Advanced URL routing and patterns allow you to manage these scenarios efficiently. In this segment, we will explore how to use advanced techniques like including other URL confs, using converters for capturing URL parameters, and creating custom path converters. In the provided code snippet, we first define a custom URL path converter class, 4-digit year converter, which specifies a regex pattern that matches exactly 4 digits. This class includes methods for converting the URL string to a Python data type to Python and vice versa to URL. We then register this converter with the name YYYY using register converter, making it available for use within our URL patterns. Finally, by using the path articles/YYY year/, we tell Django to capture a 4-digit year from the URL and pass it as an integer to the year archive view. This approach facilitates more robust URL patterns and enhances the flexibility of your Django application's URL routing system. Celery for background tasks. Celery is a powerful, distributed task queue system often used with Django for executing time-consuming tasks asynchronously. It's useful for tasks that are not required to be done within the scope of a request-response cycle, such as sending emails, processing images, or handling bulk data operations. This ensures your web application remains responsive. In this simple Celery setup, we first import Celery from the Celery package. Then, we instantiate a new Celery object called app, specifying a name for our task queue, tasks, and the message broker, pymqp/guest localhost/ that Celery will use to communicate between the task producers and consumers. The decorator @app.task is applied to the function add, effectively turning it into a background task managed by Celery. This allows the function add to execute asynchronously outside the request-response cycle and can be called from anywhere in your Django project. Using a message broker like RabbitMQ, in our example pymqp, enables Celery to efficiently distribute tasks across multiple workers. Django channels for WebSockets. Django channels extend Django to handle WebSockets, enabling real-time features and async processing. This allows for functionalities such as chat applications or live notifications. WebSockets provide a persistent connection between a client and a server, enabling bidirectional communication without the need for repeated HTTP requests. This code snippet defines a basic WebSocket consumer in Django using channels. The chat consumer class inherits from async WebSocket consumer and implements three key asynchronous methods: connect, disconnect, and receive. Upon a WebSocket connection request, the connect method accepts the connection. The disconnect method handles disconnection scenarios. The receive method processes incoming messages and immediately echoes them back to the client. Communication data, both received and sent, is structured in JSON format for easy parsing and consistency. This example lays the groundwork for real-time chat features, showcasing the capability of Django channels to facilitate WebSocket communications. Project structure and Django apps. An efficient Django project structure promotes scalability, readability, and maintainability. Django projects are comprised of individual applications, apps, that are aimed to execute a particular service or feature. Structuring these efficiently is crucial for project success. In this structure, My Project is the root directory containing the project configuration and individual apps, App 1, App 2. Each app is a Python package with its models, views, and controllers. Manage.py is a command line utility that lets you interact with this Django project. The migrations directory holds migrations files, which are auto-generated by Django to track and implement changes in your database schema over time. This structure ensures a clean separation of concerns, facilitating development and maintenance. Internationalization and localization. Internationalization, I18N, and localization, L10N, enable your Django application to support multiple languages and cultural settings. By implementing these, your app can cater to a global audience with localized content. First, you need to enable localization in your settings and mark strings for translation. In the code snippet, the getTextLazy function is used to mark strings for translation, allowing Django to translate these strings into the preferred language of the user. Languages is a tuple that defines the languages offered by your application. Language code sets the default language. Use I18N is set to true to enable Django's internationalization framework. Similarly, use L10N is set to true, enabling Django's localization framework for formatting dates, numbers, and calendars according to the user's locale. API versioning. API versioning is crucial for maintaining backward compatibility while allowing your API to evolve. This example demonstrates a simple approach to versioning a Django REST Framework, DRF API using URL path versioning. This code snippet sets up a custom versioning scheme for a Django REST Framework API. URL path versioning allows clients to request a specific API version by including it in the URL path. The myVersioning class defines the available versions, v1 and v2, and specifies a default version, v1, to use when clients do not request a specific version. The version param attribute indicates the query parameter name used by clients to specify the API version. This setup enables smooth transitions to new API versions by supporting multiple versions concurrently. Django Best Practices. Django provides a set of best practices to help developers create efficient, maintainable, and scalable web applications. Incorporating these practices into your project from the start can minimize future technical debt and security issues. Let's delve into one such practice, using Django's built-in user model. This code snippet demonstrates the practice of using Django's built-in user model for handling user authentication and management instead of creating a custom user model from scratch. Leveraging the built-in model saves development time and ensures you're benefiting from Django's thoroughly tested security features. Whenever feasible, extending Django's user model or using a profile model to store additional user information is recommended over creating a completely custom user model. This approach adheres to the dry, don't repeat yourself principle, one of the core philosophies of Django.